Welcome to doassignment-ca. Here is the problem. A particle's position-time graph has been experimentally determined. From the data, construct the velocity time and acceleration time graphs for the motion over the interval 0 to 40 seconds. For 0 to 30 seconds, the position follows the equation s equals 0.4 t squared meters. For t greater than or equal to 30 seconds, the position time graph becomes a straight line. Now, let us work through the solution step by step. We have two regions to analyze. From t equals 0 to 30 seconds, position follows a parabolic equation. From t equals 30 to 40 seconds, the graph becomes a straight line, which means constant velocity. We will differentiate position to get velocity, then differentiate velocity to get acceleration in each region. For the first region, we differentiate 0.4 t squared with respect to t. Using the power rule, we get v equals 0.8 t meters per second. This is linear in time, so the velocity time graph is a straight line starting from 0. At t equals 30 seconds, the velocity reaches 24 meters per second. Differentiating velocity 0.8 t gives a constant acceleration of 0.8 meters per second squared. So, for the first 30 seconds, the acceleration time graph is a flat horizontal line at 0.8 meters per second squared. In the second region, the st graph is straight, meaning velocity is constant. For continuity, the velocity at t equals 30 seconds must match the value from region 1, which is 24 meters per second. The position at t equals 30 is 360 meters. So the position equation for the second region is 360 plus 24 times the quantity t minus 30. Differentiating the position in region 2 gives a constant velocity of 24 meters per second. Differentiating that gives 0 acceleration. So in region 2, the velocity time graph is a flat line at 24 meters per second, and the acceleration time graph drops to 0. At t equals 40 seconds, the position is 360 plus 24 times 10, which equals 600 meters. This confirms our equations are consistent. To summarize, the velocity starts at 0, increases linearly as 0.8 t meters per second up to 24 meters per second at t equals 30 seconds, and then stays constant at 24 meters per second until t equals 40 seconds. The acceleration is a constant 0.8 meters per second squared for the first 30 seconds, and then drops to 0 for the remaining 10 seconds. These are the complete velocity time and acceleration time graphs for the motion. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.